Hello friends, welcome to Basic Electrical YouTube channel. So in this lecture, we are going to learn derive EMF equation of an alternator. Very important derivation and also very easy. This question regularly asked for examination for 6 to 8 marks. Either they will ask EMF equation of an alternator. Otherwise, if the derivation is not came for exam, definitely there will be one problem on alternator. If you know the derivation correctly, you can easily solve problems. Okay. So let me start. Class number 10. Okay. Last theoretical topic on synchronous generator. Next lecture will be problems on alternator. Okay. So let's start. So before starting derivation, you have to list down some notations. Okay. So let capital P is nothing but, along with me you can write number of poles. Capital P is nothing but number of poles. And then capital Z, nothing but total number of conductors. Total number of conductors are connected in series. Total number of conductors are connected in series. That is denoted as Z. Next is ZPH. Z suffix PH. Okay, don't write like this. ZPH. You write Z, suffix you write. Okay, don't write continuous word. This is correct. This is wrong. This is correct. Okay. See now, ZPH means total number of conductors are connected in series, as it is same definition from till here to here, but you should write per phase. ZPH is nothing but total number of conductors are connected in series per phase. Okay, and there is a formula for this. ZPH is equal to Z by 3. There are so many conductors, but if I want to divide those conductors per phase for a 3-phase machine, okay, for a 3-phase alternator, okay, for a 3-phase alternator, ZPH is written as Z by 3. For 5-phase, you write Z by 5. So for 10-phase, you write Z by 10. However, commonly we are using 3-phase alternator. So ZPH formula is Z by 3. So next is TPH. TPH is nothing but total number of turns. Total number of turns per phase. Total number of turns per phase. So formula for that is, TPH formula will be ZPH divided by 2. Turns per phase formula is ZPH by 2. And then pi means flux per pole in Webers. Okay, flux per pole in Weber. Pi is nothing but flux value. Flux generated per pole. Okay, that is in Weber. So next is, another one is NS. See, alternator runs at specific speed. That is called synchronous speed. NS is nothing but synchronous speed. Alternator runs at only one speed. That speed is called synchronous speed. So it is also called synchronous generator. Okay. So any other data, now you write F. F is called frequency of induced quantity. F is nothing but frequency of induced EMF. So this black is not working. Let me take another black color. Okay, black marker. Frequency of induced EMF. So these are the notations I am going to use in the derivation. So let me give clarity. What is ZPH and TPH? What is turn? What is conductor? I am going to give clarity for that. See guys, this is one conductor and this is another conductor. This is one conductor, this is another conductor, conductor 2. So if I join these two conductors, see, I joined these two conductors. Okay, then this entire thing from here to here, this entire thing is called one turn. Okay, then it is called one turn. To make it one turn, how many conductors I have taken? 2 conductors I have taken. So therefore you can tell one turn, to make one turn you require 2 conductors. Conductors are denoted by Z. For one turn, 2 conductors. Let's assume in the alternator there are 480 conductors. Okay. Assume there are 480 conductors. Now the same data I want to represent it in how many turns? There are 480 conductors. One turn requires 2 conductors. For 480 conductors becomes how many turns? 240 turns. Okay. 240 turn. Okay. So 240. One turn. To make one turn, how many conductors? 2 conductors. 240 into 2, 480 conductors. Similarly, now conductors per phase is what? Z by 3. How many conductors are there? 480 conductors. Okay. In that 480 conductors, how many conductor goes to R phase? How many conductor goes to Y phase? And how many conductor goes to B phase? Because 3 phases, no? R phase, Y phase, B phase. Now if I divide by 3, how much you will get? 3 1 jar 3. So 1 is the carry. 3 6 jar 18. So getting 160 conductors. In each phase, there are how many conductors? 160 conductors per phase. In the same data, this many number of conductors are there in one phase. Then how many turns in one phase? So then you can write TPH will be ZPH by 2. What is ZPH? 160 divided by 2. How many turns in one phase? In one phase there are 80 turns. Okay. So what is the total number of turns? Total number of turns is 240. Total number of conductor is 480. Total number of conductors per phase is 160. Total number of turns is how much? 80. So that is the mechanism here. Okay. So remember, one turn means we require how many conductors? 2 conductors. Very good. Okay. So if you need, you can write it in a rough part. Okay. I am going to erase this. Understood, guys? For 2 turns, to make 2 turns, how many conductors required? 4 conductors. 10 conductor is equal to how many turns? Very good, 5 turns. Excellent. Okay, very good. See now, these are the data required. Okay, pause the video and then copy down neatly. So now, now actual derivation starts. Okay, now according to Faraday's law of electromagnetic induction, FLEMI, Faraday's law of electromagnetic induction, the average EMF induced in a conductor, average EMF induced in a conductor is given by, you can write like this, EAV is equal to d pi by dt. Take this equation number 1. Okay, if you want, you can write change in flux by time taken to change the flux, rate of change of flux. According to Faraday's law of electromagnetic induction, the average EMF induced in a conductor means one conductor. In a conductor is given by EAV is equal to d pi by dt. Now assuming conductor rotates 1 revolution. Assuming conductor rotates 1 revolution or 1 rotation. Okay. Whenever conductor rotates 1 revolution, so let me write a figure here. So north pole and north, south, understanding purpose only. Okay, north and south. So don't write this figure. See, now I am taking one conductor. So this conductor is assuming this conductor rotating 1 revolution. Okay. So between the conductors, between the poles, there will be lines of flux. Okay. These are the lines of flux. So whenever conductor starts rotating, whenever conductor rotates, either clockwise or anti-clockwise, whatever it may be, whenever conductor rotates 1 revolution, this conductor going to cut the flux. This is called flux. This conductor cuts the flux produced by all the poles. That is called change in flux. Okay. Assuming conductor rotates 1 revolution. Okay. Therefore, the change in flux due to flux cutted by all the poles. Okay. d pi is equal to pi into p. The net change of flux is nothing but whatever the flux produced by all the poles, all that flux is cutted by this conductor when conductor rotates. When our conductor runs, this conductor cut this flux produced by all the poles. That is the net change in flux. Okay. You take it, this is pi into p. You should write a sentence. Assuming conductor rotates 1 revolution, therefore the change in flux is due to flux produced by all the poles. Okay. Reason I given here. Okay. And time taken to complete one rotation. This is one rotation. How much time it takes to complete one rotation? This conductor runs at a speed called ns, synchronous speed. To make one rotation, the time required is 60 by ns. Take this equation number 3. Now substitute 2 and 3 in 1. d pi replace pi p, dt replace 60 by ns. So by replacing, we can write this easy steps pi p by 60 by ns. Further simplification, what happens? Pi p into ns by 60. Okay, is it not? So this ns will go numerator, 60 will come denominator. So take this equation number 4. Equation 4 is EMF induced in one conductor. In one conductor, this will be the EMF induced. Pi p ns by 60. So guys, till here you pause it and copy down. I want to proceed the derivation. I want to erase this. I think you have copied down all this. If not, pause the video and then copy down. Because I want to continue from there onwards. Okay guys, so now you writing the same step here. EAV is equal to pi p ns by 60. So taking that equation number 4. Same step I written here, but you need not to write again and again. Okay guys, we know that what is frequency of induced EMF in an alternator? I explained in working principle of alternator. What is the formula we got? F is equal to, very good, PNS by 120. Okay, we know that the frequency of induced EMF is PNS by 120. Now for simplicity, I am changing this 120 in the denominator. Like this I am going to make it. 2 into 60. Can I write this 120 as 2 into 60? You can write 3 into 40. But I am going to write 2 into 60. The reason is, see, now I can group this part. PNS by 60. PNS divided by 60. What I can write? So I can write 2 times of F is equal to PNS by 60. So now in this equation 4, what I can modify? PNS by 60, I can replace it by what? 2F. So this ratio, you can put it here. So that we can write pi is there. And what is PNS by 60? 2F. Very good. Okay. So in proper order, we can write like this. 2 pi f volts. So take this equation number 5. See, this is EMF induced in one conductor. Now I am taking average EMF induced per turn. For one turn, how many conductors required? 2 conductors. Okay, 2 into average EMF induced in one conductor. In one conductor, this much voltage we got. Okay, for one turn, we need 2 conductors. Therefore, you will get average voltage per turn 2 into EAV. What is that? 2 into 2F pi, that becomes 4F pi volts. Okay, this is average voltage per turn. See now, in alternator, the induced quantity is AC. Okay, all AC quantities are represented by RMS value. DC quantities by average. I have represented in average. I want to convert this average into RMS. Okay, for a pure sine wave, in order to relate RMS and average, what is the factor we know? We know that form factor. Very good. Okay. So now form factor is equal to, what is the value of form factor? 1.11. Why I have taken 1.11? Assuming induced voltage in alternator is pure sine wave, then form factor will be 1.11. What is the formula for form factor? It is defined as the ratio of RMS by average. Very good. Okay, it is defined as the ratio of RMS by, okay, that is ERMS by E average. Okay, here I am taking E average per turn. Then what happens? We get RMS voltage per turn. No, so this one we can write it as like this: E RMS. Okay, per turn. Okay, RMS per turn. Okay, it is not division. Okay, RMS voltage per turn is equal to, multiply this into this, 1.11 into average voltage per turn. Okay, average voltage per turn. So now 1.11 into, what is average voltage per turn? Average voltage per turn is how much? This one, 4F pi volts. 4F pi volts. So multiply this, multiplying this, how much you will get? 4 into 1.11, how much? Very good, 4.44 F pi volts. So this is RMS voltage induced in one turn. Average voltage one turn is 4F pi. RMS voltage per turn is 4.44 F pi volts. So therefore you can write RMS voltage, RMS written in capital letters. Okay. Here also you can write capital letters. Okay, RMS per turn. RMS per turn. Okay, got it? So now till here you can copy down. Later I want to proceed further. So I am going to erase this side. Okay. Yes students, pause the video and then copy down. I am going to erase this one. Understanding, no? Very easy. Derivations are very easy to proceed. Okay, step by step. So now assuming there are so many turns. In one turn, we got 4.44 F pi. If there are 100 turns, you multiply by 100 times, then you will get the voltage for 100 turns. In general, we can write induced voltage per phase is equal to 4.44 F pi into TPH. What is TPH? Number of turns per phase. So now you take only one turn in one phase. One turn in one phase. You put TPH is equal to 1. Then what happens? 4.44 F pi. You got same equation. What is that? RMS voltage per turn. What is now written? RMS voltage per phase. For per phase you take that many number of turns in that phase. Okay. So this is the EMF equation of alternator. So take this equation number 6. Below this you will write down equation 6 is basic EMF equation of alternator. Okay. So this is equation 6 is basic EMF equation of an alternator. Then what is exact EMF equation of an alternator? Okay. See, the alternator will have windings, no? Armature winding. That armature winding may be lap connected or wave connected, and maybe single layer winding or maybe double layer winding, maybe concentrated winding or maybe distributed winding, maybe simplex winding or duplex winding, maybe progressive winding or retrogressive winding, maybe fractional slot winding or not fractional. Okay. See, the lot of winding is a separate subject. Okay. So if I consider winding factors, then your EMF equation slightly modifies. Okay. So therefore I can write here, by winding factors, by taking winding factors, okay, you write here, by considering winding factors, the EMF equation is given as EPH is equal to 4.44 F by TPH Kc into Kd. This is the exact EMF equation. Okay, while solving problems, you have to use this formula only. Okay, equation 7 is exact EMF equation of alternator. Very easy to remember, no? 4.44 F by TPH Kc Kd. See, now the product of Kc and Kd is nothing but winding factor Kw. Kw is nothing but winding factor. In problems they will specify the winding factor is 0.97. Then you need not to calculate Kc and Kd. Directly you take all together values given in the data itself. Okay. So now further, okay, we need to analyze much more about this. See, Kc is nothing but pitch factor. Okay, pitch factor or carding factor, pitch factor or carding factor, or another name is coil span factor. Coil span factor. So Kc can be calculated by this simple formula, that is cos numerator alpha denominator divided by 2. Cos alpha by 2. Using this formula you can calculate pitch factor value. Okay. Okay, got it? What is your alpha? What is your alpha? Alpha is nothing but carding angle. Okay. Alpha is nothing but carding angle. See guys, 99% they won't ask you to calculate what is the value of Kc. Okay. Calculating Kc is not in your syllabus. Okay. It is higher level topic. So however, then you must know something about Kc. Okay. So you can take Kc value 1 only. You take Kc is equal to 1. When you must take Kc is equal to 1? When winding is full pitched. Okay. For full pitched winding, in problem they will specify the winding is full pitch. Then only you take Kc is equal to 1. If it is short pitch, then you must calculate Kc. 100% I will promise. Okay. This calculation of Kc will not come for exam. Okay. All problems on EMF equation of alternator, you simply close your eyes and take Kc is equal to 1. But sometimes you should open your eyes because they will give Kc value. They will give Kc 0.992. At that time you take that value. Okay, when not at all data given, you take full pitch only. Okay, full pitch means Kc is equal to 1. Short pitch means you have to calculate Kc. For that you have to calculate alpha. Calculating alpha again for the higher level topic. Okay, that not comes for first year. Okay, curriculum. Okay, got it guys. So Kc is understood. Now Kd. So please pause the video, copy down. I am going to write Kd somewhere here. I am going to erase this part. Very easy derivation. Okay. So now Kd is nothing but distribution factor. Kd is nothing but distribution factor. So I will explain much about this. Very interesting also. this one you need to calculate. Okay, so let me see the formula. Distribution factor is given by KD formula is, okay, sine, numerator sine, okay, m beta by 2 divided by m sine beta divided by 2. Okay, m sine beta by 2. This is value of KD. So distribution factor is calculated by this formula, sin m beta by 2 by m sin beta by 2. Again here two unknowns. We don't know what is m. See, m is nothing but slots per pole per phase. Okay, slots per pole per phase. That is nothing but m. How to calculate? See, they will give all this data. Slot, they will give pole. First you divide slots by pole. How much answer you are getting? That answer divide by number of phase in the data. If they given 3 phase, you divide by 3. First method is divide this and this. What answer you got? Divide by this. That is the value of m. And you should get m value exact integer, like 1, m should be 1, m should be 2 or 3, 4, 5, like that. But it should not come fraction. However, in problem, they can give data as they like. Under such condition, you may get value of m 1.5, 2.5, 3.5, 3.49, 5.6 may come. Okay, need not to worry. Calculator is there, Calc will do it. You need not to worry. Okay, that is m meaning. Next, beta. Beta is nothing but slot angle. Beta is nothing but slot angle. So there is another small formula for beta, that is 180 degree divided by n. 180 divided by n. From this you can calculate beta value. So then what is n? Again one unknown, n. See, n is nothing but the ratio of slot per pole. How many slot and how many poles? Divide this ratio. How much you got n? That is slots per pole. Take that n value, put it here, you will get beta. Take this beta, put it here. Calculate m, put it here. Keep the calc in degree mode. Then calculate KD. After calculating KD, put it in the equation. Remaining all other values they will give. In problems you can understand much better. Okay guys, got it? So now, in a question, they will give the winding is distributed. Okay, they will specify in the question the winding is distributed. Under that condition only you must calculate KD. Remaining condition, don't calculate KD. What is that remaining condition? Okay, you take KD value always 1 for concentrated winding. KD is always 1 for concentrated winding. Okay, got it? You must take KD value always 1 for concentrated winding. In the question, if they given distributed, you must calculate KD. 2 to 3 marks will be there for this calculation. Okay, got it? Understood, guys? See, till here you must write. If they ask derive EMF equation of alternator, after writing this, you give clarity for Kc and Kd. Write Kc formula, write Kd formula. When Kc becomes 1, when full pitch winding. When Kd becomes 1, when concentrated winding. Okay, guys? So please pause the video and then copy down. Okay, very easy derivation. Now only for knowledge purpose, I want to give clarity. Sir, what is distributed? What is concentrated? Okay, for that I will give clarity. So it won't come for exam, but understanding is also very important. It will help at some times. Okay, see, look at here. Okay friends, look at here. Now I am going to give clarity for what is concentrated winding and distribution winding. Let me take some example. 18 slots are there and 18 conductors, total conductor, and a 2-pole 3-phase alternator. Okay, so there are total 18 slots, 2 pole. How many slots per pole? 18 slots divided by 2. You will get 9 slots comes under one pole. So these 9 slots I have written. This is called slot 1, 2, 3, 4, 5, 6, 7, 8, 9. All these 9 slots comes under north pole, and another 9 slots. All these 9 slots comes under south pole. Okay. So now in that 9 slots, how many slots per pole per phase? That is calculated by this. How many slots? 18 slots. How many poles? 2. 18 by 2, 9. 9 by 3 phase machine. 9 by 3, 3. Means in one phase we require 3 slots. Okay. 3 slots comes under per phase. Okay. 3 here, 3 here. R phase, Y phase, B phase. 3 phase machine. So now there are 18 conductors. I want to place this conductor. 18 slots. Each conductor carry 1. Each slot carry 1 conductor. If I place, there are 3 conductors, comes under one phase. Okay. If I place all those conductor in one slot only, all the 3 conductor one slot itself, and making the remaining slot empty, this type of winding is called concentrated winding. How many conductors comes under per phase? All those conductors are putting in one slot only. Another slots making empty. That is called concentrated winding. Nowadays we are not using. Okay, got it? Similarly, the same winding, same conductors. There are 3 conductors in R phase of north pole side. So if I place all the 3 conductors, okay, equally distributed in all the slots. 3 conductors, 3 slots. 1 conductor in all the slots. This is called distributed winding. See, this type of winding will give accurate induced quantity. Quality of the induced waveform is almost sinusoidal. Okay. You may get reduced induced voltage. Little bit induced voltage will get reduced, but quality of the waveform is good. Okay. In concentrated winding, you will get more voltage, but quality of the waveform is not good. Okay. It becomes non-sinusoidal because you are wasting the slots. You are not effectively utilize the slots. Okay. Understood, guys? What is the difference between concentrated and distributed winding? So next is the range of KD and KC. See, KD value, if you calculate KD value, 100% they are going to ask KD calculation. When you must do KD? When they specify distributed in the question. Okay, the winding is distributed. Then only calculate KD. Okay. If they given concentrated, simply close your eyes, take KD is equal to 1. Okay. Then if I calculate what could be the value of KD, your KD can predict from 0 to 1 only. KD value never become negative, and it won't become more than 1 also. If you got more than 1 KD value, that indicates you have done something wrong. Okay, got it? Next, KC also varies from 0 to 1 only. If it 99%, there is no calculation of KC. They will specify in the question full pitch winding. Full pitch means you can take KC is equal to 1. Okay. Short pitch means you must calculate KC. Calculation of KC not at all in the syllabus. So need not to worry. Simply close your eyes and write KC is equal to 1. Okay. So if you calculate KD, you should predict the answer within 0 to 1 only. Got it, guys? So pause the video, copy down all these concepts in a neat manner. So meet you on next lecture, problems on alternators, your most waiting lecture. So I'm going to upload in the next 1 or 2 days. Okay. Okay, guys, tell this content to all your friends. Tell them to become member to our channel. Okay, keep supporting my channel so I can spend my extra personal time to interact with my members regarding this subject and to score good marks in this particular subject in university examination. If the support continues in the same way, I am going to do a video lecture for second semester. You are going to become C-cycle students. In C-cycle, another subject related to basic electrical, basic electronics are friends. Okay, basic electronics I am going to do it. Basic electronics and communication. That subject I am planning to do videos. I will decide based on the support received from this basic electrical lectures. Okay, have a nice day. Take care. Meet you next lecture. Problems on alternator.